Alright, so this is the review for chemistry, Unit 1 review. We'll start off with the matching. Pretty much you need to pause it if you miss some of the answers. 1 is J, 2 is F, 3 is M, 4 is B, 5 is P, 6 is H, 7 is D, 8 is O, 9 C, 10 A, 11 G, 12 L, 13 E, 14 I, 15 N, 16 Q, 17 K, and 18 R. Again, if you need to, go ahead and pause it and go back to that. Alright, moving on. Let's look at significant figures. Alright, so I have my 4th period class with me. Everybody say hi. Hi. It's filmed before a live captive studio audience. Alright, that being said, sorry about the squeaky chair. Someone stole it during summer school. Alright, so let's look at significant figures. So for number 1, class, what do y'all think this answer is? Okay, so we have a decision between 3 and 5. So here's the deal. The way we decide the difference between the two of them is we have these leading zeros. That's what's making you not say 5, or sorry, the trailing zeros. That's what's making you not say 5. The only time these zeros out here are not significant is if there's not a decimal place. So what do I mean by that? Well, if we look at this one right here, there's no decimal place. So for number 2, how many sig figs do we have, guys? 1. But for number 1, what we have is a decimal, and it's to the right of a non-zero digit, i.e. 4. So that means that these guys are significant, and I have 5. So it's the same thing for number 3. Everybody, how many do we have? 4. Because all these zeros are significant because it's to the right of a non-zero digit, and it's to the right of a decimal, or a decimal is present. What about number 4? How many do we have? 2. Number 5? 4. Because these guys, what are these guys called out here? Leading zeros. Okay. Now we saw some of this whenever we did dimensional analysis, and we did our conversions between grams and kilograms or milligrams, stuff like that. What ended up happening is that you would end up starting with 12.3 milligrams, but whenever you converted it, you would have a lot of zeros there. The reason why those aren't significant is you don't get more accurate as you go up your scale. So scientific notation, everything that's in front of the X is significant. So how many sig figs do I have? Now, even if I have 1.000 times 10 to the 5th, how many sig figs do I have there? 4, okay? Whatever's in front is significant. What about number 7, how many do I have?
5.
Number 8? Because they're all non-zero digits. Number 9, how many do we have? 8. Number 10?
7.
11?
5.
12?
6.
All right, 13. 13 is 7, because all these guys are significant in there. 14 is what? 1. 15? And 16? 9. Very good, guys. Okay, so let's look at math with sig figs. All right, so again, as a reminder, if you are adding or subtracting, least decimal places. If you're multiplying or dividing, least sig figs. Okay, so let's look this up here. Number 1, are we adding or subtracting? Yeah. How many decimal places am I going to round to?
3.
None. No decimal places. All it is 454 plus 12 gives me 466, and I'm done. I don't round sig figs. I only round decimal places on addition and subtraction. What about number 2? Is it least number of decimal places? Least sig figs. Sig figs, okay? We'll come back to that later. I want to focus on addition and subtraction. So look at number 3. How many decimal places do I round to? 4. 4? 4? 2? How many decimal places do I round to? None. I have no decimal place right here. So what's 14 plus 12, guys? 26. That's it. That's all we got. All right, look at number 4. How many how many decimal places do we round to? 1. Okay. Anybody got an answer for me? I got 3.5. Because that 3 right there is less than 5. It's okay. Okay. Now for number 5, in case I didn't tell you in class, you need to put 4.120 times 10 to the negative third. Reason why, I didn't realize it when we were going through this, but that number gives you something that I don't want to cover because it's a little complicated. So just deal with that. You're going to round to 4 sig figs. Again, we'll get back to that later. So look at number 6. How many decimal places do I round to? 2 decimal places. Right there and right there. Because that's my decimal place. You got it. Anybody got an answer for number 6? Anybody?
I got 110.58.
5, 8, 5. Okay, so that rounds to 110.58. All right, so you gotta get the gist of adding, subtracting, releasing our decimal places. All right, so let's look at number 2, sig figs. All right, whenever I multiply these together, what do we get, guys? Before rounding, if you don't mind.
Before rounding?
Yes, before rounding. 1 something. 117,649. Okay, so how many sig figs am I going to round to? 3. So underline, circle. Is that greater than 5? Yeah. So that number does what? The 7 goes up to an 8. So I get 118. Now, is that it? Is that my answer? 0, 0, 0. Okay. The only time you don't put zeros in there if they're to the right of a decimal place. Okay. Basically what happens here, whenever we multiply these two numbers together, it's like taking the scale or taking the weight of a semi-truck. If you were to jump on the back of the semi-truck, would your weight affect the scale? No, because the scale for a semi-truck measures in tons, and you guys do not weigh a ton. The fattest person alive weighs about half a ton. They might tip the scales. You are not that fat. No one is. And no one should ever be that fat. That's my personal opinion. All right. Let's look at number 5 right quick. Now, for those of you at home, it's going to be a little hard to do this, but I want you to try. You get your calculator out, your 83 plus 84, whatever it is. You're going to turn it on, and then you're going to put in 5.342. Now, you come to the times 10. I do not want you to put times 10 caret sign. Instead, I want you to put second comma sign. I want you to push second comma sign. You should see an E right there. That E is times 10, okay? So you put in 5.342, second, comma sign, and then a 7. That gives you your times 10. You're going to multiply that by 4.120, second, comma sign, negative button, 3. And then you press enter. Now you see why I didn't want you to do 3 sig figs.
Wait. What do we do again? Times.
Unpause. All right. So we have this number 22090.4. How many sig figs should I round to, guys? 4. 4 here, 4 here. So do 1, 2, 3, 4, underline, circle. So that 9 is greater than 5, yes? Okay, so what's my answer going to be? 0, 0. Do not forget those zeros.
So we don't put it into significant.
Scientific notation?
Scientific notation.
No, that's all right. All right. That's pretty much all I'm going to do on those. Unless y'all want me to do another one. Number 9?
Yeah. I got a significant notation for it.
You probably will.
Number, and then I got times 8.
Okay, so 8, 9, I mean, basically all you're doing for 9 is if it gives you a number in scientific notation. All right, so I had a question about number 9.
Yes.
So if you put those into your calculator, what you end up getting is 1.025 times 10 to the negative 4th. Now, the reason why I put out 4 is because I have 3 right here, so that's what I'm going to round to. So I underline that, circle that, that's 5 or greater. You end up being your answer as 1.03 times 10 to the negative 4th. You do round in scientific notation. Alright, so let's look at number 8. I also had a question about that. 13.232 plus 11.6. Okay, how many decimal places am I going to round to?
I don't understand one.
1. Because you only have 1 decimal place right here. While over here you have 3. Okay, so I add them up, so that's 24.8. And that's it. Okay?
I think it's a 5.
Alright, stay around for part